Welcome to this series titled Understanding the Agrobiology of Agrochemical Formulations. This is Course 1, Plant Physiology and Anatomy, Understanding the Barriers to Active Ingredient Uptake and Translocation. My name is Harry Teicher. I am course trainer on the Understanding the Agrobiology of Agrochemical Formulations course series. After more than 20 years in academic and industrial crop protection R&D, I founded Bioscience Solutions in 2017 to provide independent support for the development of sustainable crop protection solutions. I am the co-founder of Frontloader Group, an independent collaboration that addresses the need for external front-loading of crop protection projects to identify and solve development obstacles. I am the author of the Lab Coat Guide to Crop Protection book series and an external lecturer at the Adama Center for Novel Crop Protection Delivery Systems at Tel Aviv University. I look forward to guiding you through the Understanding the Agrobiology of Agrochemical Formulations course series. If you have additional questions, please feel free to contact us. In this course, you will learn more about the barriers to active ingredient uptake and translocation, including about the leaf cuticle, intra- and extracellular transport within the leaf, xylem and phloem transport, as well as systemic and translaminar movement. The focus of this course, as well as the subsequent course in this series, will be on the barriers and challenges to pesticide bioavailability. Pesticides comprise substances or active ingredients which prevent, destroy, or control pests and diseases. And the biological activity of a pesticide is determined by its active ingredient, or AI, which may be formulated to improve handling, storage, application, and bioavailability. Bioavailability refers to the extent a substance or active ingredient becomes available to its intended biological target site. This, in turn, is determined by the active ingredient concentration at the site of application, such as the surface of a leaf or the insect target. Bioavailability is also determined by the anatomic and physiological characteristics of the absorptive site, which is the topic of this course. Here we will discuss plant morphology, which is the description of the physical form and external structure of plants, as well as plant physiology and plant anatomy, which are the general terms for the study of the internal structure of plants. Finally, bioavailability is determined by the active ingredient solubility, determined in turn by its log P, pKa, the pH of the surrounding environment, the molecular size range. And this will be covered in the following course. The bioavailability of a pesticide, or the extent a substance or active ingredient becomes available to its intended biological target site, can fall as much as 3 orders of magnitude before reaching the target site itself. The first order of magnitude loss of the active ingredient to the target site comes through a cascade of factors including precipitation of the active ingredient in the spray tank and degradation of the active ingredient in the spray solution or in the bottle itself. The loss can also be due to drift of the spray droplets, missing the target plant or insect entirely, premature evaporation of the spray droplet, leading to reduced uptake of the active ingredient into the leaf, losses through bounce, runoff, volatility from the spray droplets, wash off by rain and dew, degradation of the active ingredient on the leaf surface, for example through hydrolysis or UV degradation, as well as irreversible binding to the lipophilic cuticle layer on the leaf surface. For the 10% of the active ingredient actually reaching the target plant leaf surface, there is the next challenge to be faced regarding the delivery of the active ingredient to the target site. The uptake of the active ingredient across the cuticle and into the leaf can be optimized using formulation adjuvants. But once inside the leaf, the active ingredient is essentially left by itself. It doesn't have the protection of the formulation technology, and it may be recognized within the plant as a xenobiotic, as a foreign molecule, conjugated typically with the glutathione molecule and sequestered to the vacuole, where it is targeted for degradation. And finally, the physical-chemical characteristics of the active ingredient will determine whether the active ingredient moves through the plant to the target site and binds to the target site as opposed to non-target binding. For the first order of magnitude loss of active ingredient from the spray solution to the leaf surface, formulation technologies can address the issues of precipitation, degradation, drift, bounce, degradation on the leaf surface, and binding, etc. For active ingredient delivery to the target site, delivery technologies heavily based on developments in the pharmaceutical industry for drug delivery are emerging as solutions to optimize the delivery of the active ingredient to the target site. We will discuss some of the delivery advances taking place within the agrochemical industry, but within this series we will focus primarily on formulation technologies.